Continuing on with your review with the graphs of f of x and graphs of f prime of x and what we can find from them. First, if we're given a graph of f of x, this should be very easy to find everything we need. Critical numbers are numbers where you would have a maximum or a minimum, where the slope would be 0. So that's just where you have a max here, or a min here, a max here, and a min there. So those occur when x equals negative 4, negative 2. So negative 4, negative 2, and positive 1 as your three critical numbers with a max or a min. Now, identifying each one. The maximum is going to occur right here at x equals 2. If you wanted to put it as a point, it would be, or negative 2, it would be negative 2 comma 2 is the value there. The minimum occurs at two different places, x equals negative 4 and positive 1. Those would be the points negative 4 comma 0 and the point 1 comma negative 5. Those are the minimum values. Increasing and decreasing regions. Just think this means slope. Increasing regions mean you have a positive slope. You're going upwards. So that would occur in this region right here from negative 4 to negative 2. And then again from this minimum at 1 up all the way to infinity. Decreasing regions mean a downhill slope. So that's from negative infinity up to negative 4. And then again from negative 2 to 1 as you're going here down yet again. Points of inflection are a little bit tougher to see. That's where you should be changing from smiling to frowning. Well, I'm going to start with a smiling region here. And then right about in this area, it looks like I'm switching now to something that's curving downward because I'm getting towards a maximum. And then again, as I'm going down here, eventually, probably somewhere in here, I'm changing from this frowning looking face to start curving back upwards to smiling again. So those 2 points that I just drew would be my points of inflection. Those would be at x values of, I'm going to call that one about negative 3. And I'm going to call this one, it's not quite to 0, so I'll probably call it like negative 1/2. As long as you're approximating it, you should be all right. Now, concave up means it's a smiling region, so that's right in here. That'd be from negative infinity up to that point of inflection, negative 3. And then also for this part down here. So that'd be like, if we said negative 1/2, that'd be negative 1/2 up to infinity. Concave down would be the points here in the middle, this downward curving region. So that'd be from negative 3 to negative 1/2. So that's the way you do it with a graph of f of x, but let's look at the exact same graph, but now we're going to call this the graph of f prime of x, the derivative of f of x. So critical numbers are when the slope is 0, the derivative is 0. Well, we already have the graph of the derivative, so when does it equal 0? Well, it's at these three spots right here when x equals negative 4, x equals negative 1, and 3. So this is when the derivative equaled 0. Max and min. Maximum meant that you went from an increasing region to a decreasing region. That means that the derivative was positive and then negative. If it helps, draw out a little number line graph here. We said our critical numbers were at negative 4, negative 1, and 3. This is what we figured out in part A. The derivative, which is the graph I'm given here, it's positive in the regions to the left of it. It's also positive in this region in the middle. Then it's negative between negative 1 and 3, and positive again because it's above the x-axis on the right. That means that my original graph, f, is increasing, increasing again, then decreasing, then increasing again. So that means my maximum occurs when I went from increasing to decreasing. That's when x equaled negative 1. The minimum means I was going from decreasing to increasing. That happened when x equaled 3. Notice, x is negative 4 is nothing right here because I went from increasing to increasing again. So that's neither a maximum nor a minimum. Okay, we can use this same little graph to make my increasing and decreasing regions. Increasing would be negative infinity to negative 4 because the derivative is positive. Then from negative 4 to negative 1 because it's positive. And then from 3 to infinity because the derivative is positive. Decreasing regions would be from negative 1 to positive 3. That's because the derivative is negative, and we already drew the graph that it was decreasing. Okay, the last part, points of inflection. Points of inflection happen when f double prime equals 0. Well, f double prime is the derivative of f prime, which is what we were given in our graph. Okay, the derivative means slope. So we want to know when the slope of this graph equals 0. Well, that happens whenever we have a maximum or a minimum value. on this graph. So that means my points of inflection will happen at x equals -4, x equals -1, and x equals, or I'm sorry, not -1. I'm ahead of myself. X equals here at -2, and then at x equals 1 is where that minimum occurs there. So if I'm looking at f double prime, we're looking at these points of inflection, which we just said we're at -4, we're at -2, and here at +1. Let's look at what the f prime is. F prime, or f double prime I mean, means the slope of, excuse me, the slope of the derivative graph. So right here, it's going downhill. That means the slope of f prime is negative. That means f double prime is negative. We're increasing here. That means the slope of f prime is positive. The second derivative is positive. Right here we're going down. That means the slope of f prime is negative. That means that f double prime is negative. And here f prime is increasing. That means that it is curving upward. That means f double prime is positive. So what that means here is we should have concave down, concave up, concave down. That would help if I would actually draw them correctly. So this was positive. Concave down means frowning. Concave up means smiling. Concave down means frowning. Concave up means smiling. So my concave up regions are where it's positive. That would be from -4 up to -2 because we just said it was positive. And then also from 1 to infinity. Then concave down would be when it's negative. So that's -infinity up to -4. And then again from -2 to 1 because the derivative value, the second derivative value, or the slope of this graph is negative. There's everything for knowing how to analyze these graphs. Take your time and just think about what the question's asking.